Here's a lab problem from section 2.5. It says here, use continuity to evaluate the limit. So here's our limit, and limit as x approaches 4 of 32 plus square root of x squared in the numerator divided by, and then in the denominator it's the square root of the whole quantity 32 plus x. So consider the intervals in which the numerator and denominator are both continuous. So when is this continuous? So it looks like it'll be continuous everywhere except for the places where this would be not defined, and it would be not defined when x is equal to x is less than 0, when x is negative. So I would include, and here I can take a look at the sets as in set notation, and I can find the appropriate set. So I want to include 0, and I want an open parentheses on the right for infinity. So I'd say 0 and then comma and then the infinity symbol, which is our basic symbol, infinity. Alright, the denominator, when is this thing not continuous? So now, because it's in the denominator, it cannot be equal to 0. When x is equal to negative 32, it's equal to 0, so that's no good. We also want it to be bigger than that, and so essentially what we're doing is we're solving for when 32, or x, or let's say 32 plus x is, we want that to be bigger than 0, and not equal to, just strictly bigger than 0. So if we solve for that, we're going to bring the 32 over to the other side. We're going to say x is bigger than 32. So again, with x is bigger than negative 32. Again, with the set notation, this time it's going to be both open parentheses. Oops, let's not do it here. Let's do it down here. So with both open, we're going to go from negative 32 all the way up to infinity. Okay, so those are the domains of the numerator and the denominator. The interval in which the quotient is continuous is the intersection of the above intervals. So therefore, this whole thing is continuous. So if we take a look at these two number lines, having negative numbers is okay for the denominators all the way up to negative 32, but it's not okay with the numerator. So we're going to take it from here and say our set where the whole thing is continuous is going to be when the numerator is continuous. So it would be going from 0 to infinity. Oops, let's actually use a symbol. And then let's close it up with brackets. Okay, so the mixed brackets aren't working by typing, so let's actually use this. So we'll use the closed bracket on the right and an open on the left, and we're going to go from 0 to infinity. All right. So now 4 is within the continuous interval, and if f is continuous at 4, then we can easily just plug in the value of 4 into this expression. So we have this expression 32 plus square root of 4. Square root of 4, I think it's 2. So I think that's adding 32 plus 2. And then we're going to divide by, and then we have 32 plus 4, so that's going to be 36, and the square root of 36. So the square root of 36 is 6. I think we can reduce this. We could divide both the top and the bottom by 4, or by 2. So if we divide this by 2, we're going to get 17, and if we divide this by 2, we're going to get 3. So 17 over 3 let's submit, see what happens. Okay, that looks good. All right, so let's take a look at the graph of this. Doesn't say we need to take a look at the graph, but we should take a look at the graph of this. If you have a graphing calculator or something, or Desmos. Here I actually found the graph, and then the graph, if I trace this, I can see that at when x is equal to 4, I get the value of 5.6666. So I think if you take your 17 divided by 3, you get 5.666, and so that's the y value that we get. Okay, so that's this problem, and I hope that helps.